Hello, thank you for watching this math intervention makeup lesson. Today we are going to be talking about properties of addition and multiplication. By the end of the lesson today, you'll be able to identify and apply the different properties of addition and multiplication. I'm Mrs. Morandi. Please make sure you have your pencil and your notebook ready, and we'll get started. The 5 properties of arithmetic are commutative, associative, distributive, inverse, and identity. These are the rules that numbers follow. So when we have you do things like the order of operations, it's because of these rules that we have rules like that, where we have to do things in a certain order so that in the end everybody can get the same answer. So let's look at some examples of these types of properties. The commutative property states that when two real numbers are added or multiplied, the order in which the numbers are written does not affect the result. The way I like to help myself remember commutative is I think of a community. So the community, you have a community of numbers where the numbers can move around, but they're still going to be in the community. They're still going to have the same result. That's just a silly way I use to help myself remember it. So putting it with numbers, for any numbers we'll call A and B. You can add A plus B, or you can add B plus A, and you're going to get the same result. That is the commutative property of addition. The commutative property of multiplication is the same thing. If I take A times B, I can also take B times A, and I'm going to get the same answer. Here are some examples of addition. Whether I take 2 plus 1 or I take 1 plus 2, I'm going to get the same result. This is the commutative property. They're in that same community, they're just moving around. Multiplication, 5 times 9 and 9 times 5 are also commutative. They're going to give you the same answer. If you were to try this with subtraction, this would not work. Subtraction is not commutative. 4 minus 3 is not the same as 3 minus 4. It does make a difference. This is why when you're doing your order of operations, we tell you to work from left to right, because if you start doing the subtraction first, it's going to give you a different answer. Division is also not commutative. 6 divided by 2 is not the same as 2 divided by 6. So only addition and multiplication follow the commutative property. The associative property states that an operation is associative if you can group numbers in any way without changing the answers. Think about what the word associate means. Associate means basically to hang out with. So the numbers can hang out with one number one time, and then it can move around and it can hang out with another number the other time. Let's look at an example of what I'm talking about. We're talking about the numbers A, B, and C. We can say that A plus B plus C, and we can group the B and C together, is the same as if we were to group the A and B together first and then add. If we took 1 plus 2 plus 3, if we were to add the 2 and 3 together first, we would still get 6 as an answer. Same thing if we decided to take the 1 plus 2 and add that together, we would have 3 plus 3, and we would get 6. So it's going to be the same answer no matter what. It's just in this first problem, the B is associated with the C. In the second way, the A is associated with the B. So this is the associative property. You can also have the associative property for multiplication. You can first multiply B times C, then multiply it by A, or you can multiply A times B first and then multiply it by C. Either way, you will come up with the same answer. We're going to look at some more examples right here. Here's the example like what I just showed you here, where we can add 3 plus 2 and then 1, or we can add 2 plus 1 and then 3. In the end, your answer is still going to be 6. Here's a multiplication example. 4 times 5 is 20, times 9 would give us 180. 4 times 5 times 9 would be 45, is also going to give us an answer of 180. Just like the commutative property, subtraction and division are not associative. It does not give you the same result if you associate the first two numbers together or the second and third numbers together. It's not associative. Same thing with division. You can see here you'd get two completely different answers if you solved this problem and if you solved this problem. The next property we're going to look at is the distributive property. This is the property that you will see the most often in algebra. Distributive is to distribute. The distributive property states that this property provides a way to change a product to a sum or a sum to a product. It's commonly referred to the distributive property of multiplication over addition. That's a mouthful, but let's take a look at what it looks like. So for any numbers, real numbers, A, B, and C, if we have A multiplying B plus C in parentheses, it's the same as multiplying this A times B plus multiplying this A times C. And you can also break it down the other way. Even if the A is over on this side, it's still going to have the same result. Think about addition. And the reason we have these kinds of properties is because we're not always going to be dealing with numbers. We're going to have variables mixed in there. So if we have rules that we know we can add things together, then it's going to help us to solve problems. So if I want to take 2 and I want to multiply this by 3 plus 1, I'm saying that I can take 3 plus 1 and get 4, and I can multiply 2 times 4, and my answer would be 8. I also could have distributed this 2 in here to say 2 times 3 plus distribute this 2 times this 1 right here, 2 times 1, and I would have gotten 6 plus 2 with the final answer of 8. So you see that these are equal. You're really going to use the distributive property a lot if instead of this 3 right here, you had an x. If this was an x right here, you definitely need that distributive property before you're able to go on and solve any sort of equation. So let's take a look at a couple more examples right here. So this is using with straight numbers, our 3s and 2s and 1s again. We can see that 3 times the sum of 2 times 1 is the same as multiplying that 3 times everything in the parentheses. Multiply it by the 2, multiply it by the 1. And here's another example here with just our 6 on the other side of our parentheses, but still it means the same thing. Our next property is the inverse property, which states that for any real number A, there is a single real number negative A such that A plus negative A is equal to 0, and negative A plus A is also equal to 0. The inverse property for multiplication states that for any non-zero real number A, there is a single real number 1 over A, so that when you multiply the two of them together, it equals 1. This is the inverse. You've also probably heard it referred to the reciprocal. Instead of A, the reciprocal or the inverse would be 1 over A, and when you multiply them together, you would get A over A, which is equal to 1. So let's look at some examples right here. So for addition, positive 4 plus negative 4 equals zeros. So these are additive inverses. You use additive inverses a lot when you're solving for equations. Here is a multiplicative inverse. You also use this a lot when you're solving for equations. 3 times the reciprocal, 1 over 3, would give us 3 over 3, which equals 1. So this is our multiplicative inverse. The identity property tells us that for any real number A, when I add 0 to it, I'm going to get A. That's the identity. It's who it is. If I add 0 plus A or A plus 0, I'm going to get A. This is my identity property of addition. The identity property for multiplication is just multiplying it by 1. If you multiply anything by 1, you're going to get itself. So that is our identity property for multiplication. And here are some examples. 5 plus 0 would be 5, and multiplication 9 times 1 would be equal to 9.